So yesterday's problem of the day says, how long does it take an object dropped from rest to reach a speed of 30 meters per second? All right, so how long an object dropped from rest to reach a speed of 30 meters per second? So we'll start, as always, by figuring out what the givens are, what information the problem tells us. So what do we know so far?
The initial,
Okay, yeah, what's our V initial, Isabella?
wouldn't it be 0 because it starts from rest?
Right, so our initial velocity is 0 because we start from rest. And then that's good. What else do we have?
Our final,
Yeah, we have our final velocity as well. What's that going to be?
30.
Perfect. All right, how long does it take to reach a speed of 30 meters per second? So that would be its final velocity, 30 meters per second. Anything else?
I think we also got the accelerations.
Yeah, we do. What's the acceleration going to be?
It's gonna be negative 9.8.
Yeah, negative 9.8, right? Because we're in free fall, right? An object's falling. So that's a hint that we're in free fall. And if we're in free fall, we always want to use negative 9.8 for our acceleration. Good. And then what would the unknown be in this problem? What are we looking for?
For restant time.
Yeah, for the time, delta t, right? How long does it take? That's asking for time. Good. Okay, so if we've got VYI, VYF, and AY, which kinematics equation should we pick?
The second one.
Sounds good to me, right? The second kinematics equation, that one has V final, V initial, acceleration, and time, just like we've put in our givens and unknowns today. So we start with this equation, right? Final velocity equals initial velocity plus acceleration times time. And we want to get time by itself, right? Times are unknown here. So what's the first thing I want to do if I want to get time by itself? If I see that it's in this term and there's a VYI added onto it.
We had to subtract the initial velocity on both sides.
Exactly, good. If we subtract initial velocity from this side, it cancels out, right? Because it's being added on to the term we're looking for. And we also have to do it to this side. So we have final velocity minus initial velocity equals acceleration times time. And now we just have one more simple step to do to get our time by itself. What's that going to be?
We had to divide accelerations.
Right, thanks, Jose. We have to divide the acceleration, right? If we want time by itself and acceleration is multiplied onto it, we would divide by acceleration. And we have to do that on both sides. So what we're left with, our final equation, is that time is going to be equal to final velocity minus initial velocity divided by acceleration. So I can plug in my numbers now. That's step 5, right? My final velocity I know is just 30 meters per second minus my initial velocity, which I know is 0. And then divided by my acceleration, which is negative 9.8 meters per second squared. Now, before I even plug in numbers, I noticed something here. If I've got a positive number up here and a negative number down there, I'm going to get a negative number for my time. But I shouldn't have a negative number for time. That means I made a small mistake somewhere. One of these numbers, one of these givens is not quite right. Can anybody tell which one?
I think we can make negative to the final velocity.
Yeah, exactly, right? Our final velocity that we said is 30 meters per second, really we should have made that negative, right? Because it's falling downwards, right? A downwards velocity is always going to be negative. So when I got down here and plugged in my number, this 30 should be negative 30 as well. And now I can see my negative signs will cancel out and I'll get a positive number for time. So even if you make mistakes, if you're paying kind of good attention to what you're doing and asking yourself if things are making sense, you should be able to catch those mistakes. like we did here. So now I just need to plug in, and I can do negative 30 minus 0. That's not going to do anything. So divided by 9.8, negative 9.8. I get 3.06. And for my units, I have meters per second divided by meters per second squared. So the meters cancel, one of the seconds is cancels, and I'm just left with seconds. And that's what I expected since I was looking for a time. And 3 seconds for an object, you know, falling to get up to that speed seems pretty reasonable to me. So it looks like we've done it all right. Are there any questions about how we did any of these steps?